Algebra 2, back at it again, this time solving exponential equations. Let's start with 2 to the x equals 7. 2 to some number equals 7. Now we can reason that it needs to be between, x needs to be between 2 and 3 because 2 squared is 4 and 2 cubed is 8 and 7 is between 4 and 8. We might be tempted to say, I'm going to put this into logarithmic form. I'll undo the exponent by making it a logarithm. The log base 2 of 7 is equal to x, but we don't know the change of base formula just yet. So what we might instead think about doing is taking the log of both sides. Now I know that sounds weird, but remember, whatever we do to one side of the equation, we must do to the other. The log of 2 to the x is equal to the log of 7. Now I'm using the common log, a hidden little invisible base 10. And the reason why I'm doing that is because on my calculator, I have a log button, and that's the common log. Now, you may notice here that x is an exponent. And when I have a power in a logarithm, I can bring that power forward using my power rule. X times the common log of 2 is equal to the common log of 7. Now, what's nice here, this times, x is being multiplied by a number. In order to solve for x, to isolate x, I'll divide by that number because any number over itself is 1. X is equal to the log of 7 over the log of 2, and this is where my calculator comes in. The log of 7 divided by the log of 2 is approximately 2.807354922. Change these into approximately, and we'll call that 2.8. Now, I can test my hypothesis by putting into my calculator 2 to the second answer, and look what I get, 7. Huzzah. Now, we're going to try a slightly more complicated problem. 3 times e to the x plus 2 is equal to 32. Now your eyes may be bugging out of your head right now, but don't worry. The logic of what we're going to do is exactly the same. We need to get the exponent by itself. I'm going to subtract 2 from both sides. 3 times e to the x equals 30. I'm going to divide both sides by 3. E to the x equals 10. Now I have got this nice, simple thing. And now I'm going to log both sides, but I'm not going to use just any log. Notice that e, our base of our exponent is e, which is a number, 2.781828459045. And so we don't actually have to solve for that. What we're solving for is x. And so what I'm going to do is I'm going to take the natural log of both sides. The base of the natural log is e, so it's sort of natural to use. The power rule brings this x forward. X times the natural log of e is equal to the natural log of 10. Now, I could divide both sides by the natural log of e, but what is the natural log of e? What does that mean? E to what number is equal to e? E to the first power is equal to e, therefore the natural log of e is 1. X times 1x, is equal to the natural log of 10. And I can go to my calculator. Notice that there is a natural log button. I press the natural log button. The natural log of 10, close the parenthesis, enter, x is approximately 2.3. We're going to go on to one more example. Let's say we have this problem. 6 to the x equals 36 to the x minus 4. This may seem slightly familiar. It might look a little bit like the problem we were doing, the last problem in our example set yesterday. Now, you might be tempted to do some log-in on both sides, but we are not going to. Let's look at this. Let's consider it. 6 to some power is equal to 36 to some power. Notice if we did some logging, we would have some different arguments, and that would be confusing. So instead, notice that 36 is really 6 squared. 6 squared to the x minus 4, we're taking a power to a power, and when we take a power to a power, we multiply the exponent. 6 to the 2x minus 8, use the distributive property, is equal to 6 to the x. Well, that must mean that x is equal to 2x minus 8. The exponents have to be the same, and we can solve for x with this simple linear equation. Negative x equals negative 8, x must be 8. Well, let's test it out. Is it true? Is 6 to the 8th power equal to 36 to the 8 minus 4, 4 power? Well, 6 to the 8th power is 6 times 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 6. 1, 2, 3, 4, 5, 6, 7, 8. And 36 to the 4th power is 36 times 36 times 36 times 36, but I notice that those 36s can all break down. 6 times 6, 6 times 6, 6 times 6, 6 times 6. How many 6s do I have? 1, 2, 3, 4, 5, 6, 7, 8.